You want to learn how to make yourself a water shader? Let's check it out. Alright, so this water shader is going to come with a few parameters that you can tweak to adjust the water to be a little more of your own. For example, if you don't want it to be as reflected because maybe you want some murky water, then you can certainly do that. You can adjust how much of this ripple effect we got going on. You can adjust the colors of the water and the color as well as the transition of the object going under the water, as you can see there. So you're going to have all of that control. And all we're going to use for our water here is a plane, but I suppose you could really use any shape if you wanted. But I'm using a plane here. And I'm just going to turn my light off. And I have two meshes. One is just my capsule here. And one is a plane with my shader on it. Alright, so let's go ahead and dive in and take a look at how to create this shader. Alright, now I've already recorded this one time, but I feel like I could explain the code a little bit better. So I'm going to go ahead and re-record this portion of it. So up to now, I still have my light in the scene. I still have my capsule with my plane intersecting it, and my plane is going to be my water. Alright, now I have some of the code here, but we're going to go ahead and explain some of that and then jump into the fragment section after. So starting at the top, we have the shader spatial, and this line defines the shader we're using, in this case a spatial shader, which is used for 3D objects. Alright, the next line is our render mode, and the render modes control various aspects of how a shader interacts with the scene. Depth, draw always, ensures the shader is drawn even when other objects would be occluding it. Right, so when other objects are in front of it, blocking it, etc. Call disabled, our second one here. Disables backface culling, so both sides of the geometry are visible. So if you had something like a cube, we would have all sides of it being rendered instead of part of that being hidden. So if you had a water block or water ball, you know, whatever it is you're going to be going with. Now with a plane, that doesn't matter too much, because with a plane, we wouldn't have the other side to show. But we are doing it here, just in case, you know, maybe you have an underwater portion of your level and they can look up, right? And then the last section here is the specular Schlick GGX, which specifies the type of specular reflection model that we're going to be using for the highlights. Now, if you're creating a material on an object, you'll probably see all these options in there, and plenty more that you can either toggle on or select from a drop down. In the shader, you set it here with the render mode keyword. Alright, next up we have a bunch of uniforms, and these are basically like variables that will allow us to access it outside of the code, as you see here in the inspector under shader parameters. Alright, so this will allow us to control the behavior externally for the shader. For instance, ramp will determine the water's depth and the color transition. Ripple is a normal map texture for the water's ripple, which you can find these normal maps all over the internet and at so many different texture websites. So you can go ahead and just find any one of them and it'll work. And the ripple factor controls the ripple strength and so on. These values are adjustable without changing the shader code, which makes it a lot more versatile. So we could use this same shader for, say, nice crystal clear water. We can use it for maybe something more along the Caribbean where we got this nice bright bluish green, or we can go with the ocean with a nice dark blue, or maybe we can't see too far down. In a pool, you can see all the way down. Then we can go into and factor in maybe some dirty, murky water, where we can't see too far down. There's not a whole lot of reflections, so we can get all of those just by tweaking these parameters. that we have set here. All right, so that'll move us on to our linearize depth function here. And this function linearizes the depth values, transforming them from the nonlinear depth buffer representation to a linear depth value. Linear depth is essential for accurate depth-based calculations, which were used for things such as the water distortion and reflections. And then we have this rotate function of ours. Sorry there. And this function is going to rotate it rotates a 2D vector. In this case, going to be our UV coordinates, right? The X and Y. By a specified angle declared in radians. So that's key there. And this will be used to create the ripple effect by rotating the UV coordinates over time. And last, that takes us down to the actual fragment section here. And if I just back that up a bit, should be able to get everything back. Here we go. All right, so ignoring what we see up there, we can play around with that water for the moment. We're just going to take a look down here at the fragment. So we're going to look at all the way up to here, all the way up to our vec3 NRM. All right, I'm just going to go ahead and split that there, just so you guys know which piece we're talking about. So we're talking about the above portion here. And whoops, this is the starting point of our main shader logic. It retrieves what it's doing is it retrieves the normal map values from the ripple texture. Right, remember the normal map that we stuck in here, adjusting the UV coordinates over time to simulate the ripples. The mix function is blending the ripples at different UV coordinates to achieve a dynamic effect. All right, the next several lines, it's going to take us up to here. I'm just going to go ahead and copy that in. All right, so that'll give us a split there. So this section here in between is basically calculating the superfice here, which is basically going to be the surface, right? So we're calculating the surface and applying the UV distortion based on the depth of the water. These calculations form the basis of the water's distortion effect, which is what we're calling the superfice here. Is the linearized depth of the water surface, right? UV calculates the UV displacement for the ripples, and the profundidad, it's a little bit of a weird word, probably saying it wrong, but that calculates the depth of the current pixel, and the distort calculates the distorted depth. So hopefully that explains that section there. That allows us to move on. And once again, I'm going to go ahead and use this to split this up. So we're looking at this section here. All right, so in this part of the shader, the lines, these lines calculate azul and verde values that influence the water's color based on depth. And the color transitions smoothly from watercolor 1 to watercolor 2. Or I might have that backwards, it might be 2 to 1, but regardless, it's a smooth transition between the two colors as the depth changes. This gives the water a natural looking color gradient that you would expect. Oh, I'm sorry, that took us just up to this section. To there. So the next section here with the Fondo. Here, Fondo calculates the background color, taking into account chromatic aberration if enabled. Chromatic aberration creates color fringing, simulating a lens effect. The fondo color is sampled from the screen texture and adjusted UV coordinates. And then that takes us to our last section here, which allows us to actually see everything on screen. If I just reset those values there, come back in, all of our values, there we go. This last section here, let's see, where did I leave that on? Yes, all right, so this next section here that we jump into, which is how we're actually able to see everything inside of our scene. These lines assign various shader parameters that control the appearance of our water. So the albedo here at the top, this sets the color of our water's surface, and it's determined based on the depth dependent color transition that we calculated earlier. The final color blends between, of course, our color 1 and 2 based on the depth. The roughness, this parameter controls how rough or smooth the water's surface appears. The rough value is used here. Metallic, again, same thing here, determines the level of metallic reflection, and this is where we're just using the met value that we declared at the top. This takes us down to our anisotropy and anisotropy flow. All right, our next two lines. And these parameters control the anisotropic reflections on the water surface, ripple factor, and the X and Y coordinate of our UV are used to set these values. Moves us down to our normals here for our water, and this sets the normal of the water surface, of course, and it's a combination of the NRM value we calculated from the normal map textures. And that leaves us with our alpha, assuming that these conditions are met. And the alpha controls the transparency of the water that it's used to create a fading effect near the water's edge. The transparency is adjusted based on the, once again, depth values. So you can see how important some of these numbers are that we would have created early on. Alright, so if I were to pull that down, we could see, in fact, I can just click on shader editor and get rid of it completely. So we can see this is the default water that we have. If I turn the light off, there you go. You can see we have this transition from our blue at the top down to a bit more of a green towards the bottom. And this is completely affected by our ramp. So as you can see, the lower the ramp value, the less you can see underwater. Whereas if we had, I'll say 10, the higher the ramp value, the longer or further down underwater you are able to actually see your object. If I were to just go right here, for example, and we change our ramp back down to 2, we can barely see the top of it, and that's it. And as we bring it up, we're able to actually see more and more. So the ramp not only is controlling that color, but keep in mind, because of that transition, we're seeing it's also affecting how far down in the water we're actually able to see. Alright, your ripple factor, which I'm going to turn the light on just to make it easier. So we see all these ripples happening here. And with these ripple factors, as you can see, as you turn it up, with 1, or turning it down with 0, you can see how dramatic of an effect that can have on your water. Just by turning up slightly, you can get these different effects going on here, right? Now, for me personally, this is one of the settings that I like having a ripple factor set at like 50, and this is obviously going to depend on the water that you're creating. Tiling, it's set by 20 at default, and you'll see if we turn that down to 1, we have something that looks a little more like maybe pool water, right? Something that's a little calmer because of our ripple factor. We're having a lot of ripples, but if we turn that down, there you go. So we can see we can get something that's a little more reminiscent of something like pool water with that. But for me, Again, I like my tiling at 50 and my ripple factor at 50. And for me, this gives me a nice, what I would feel to be more looking out at an ocean. Of course, this is all going to play factors into your own projects, but again, it's just one of the things I like personally. And Met gives us our metallic from 0 to 1, and you can see how that affects the water. Now, because it's water, you're probably going to have a pretty high metallic, which is why we're just using 1 as a default anyway for our water. And the roughness, of course, the smoother it is, the more light that's going to be able to reflect off of it. And the rougher it is, the less light is going to be able to reflect off of it. So if we turn our roughness up, and maybe turn our metallics down, turn down tiling and the ripple factor, we can get almost more of a murky look, right? So we turn our ripple down, or not ripple, the ramp down to maybe 0.5, and you can see we start getting more of a dirtier water kind of look to it. All right, you can even turn ripple factor all the way down to 0 if we wanted to, but that's a little extreme. Maybe 0.1, so we can have a little something, but you can see we're getting this gross water as we move on. And that, again, takes us on to our water here that we get here. So we have water 2, color 2, which is going to affect the top side here. If I go with a lot of red, I'm just going to go ahead and reset those numbers. Also, personally, the roughness that I prefer is 0.1 for water. But of course, you can affect this however you would like. As you can see, watercolor 2 is really going to affect the surface, and watercolor 1 is affecting that depth, remember, so that color that we're going to see for things underwater. So if I go for a green underwater, there you go. Whoops, I want to grab that, I want to grab the capsule. So you can see that. So you can see how underwater we're going with this green, and then it's going to transition back down into our red once we go deep enough, which is why we can no longer see it underwater. So that's why our depth becomes very important as well. And you can see all that distortion that we were talking about right around the edges of our capsule. Alright. And there you go. There's a water shader. Hopefully I explained it better this second time around. The code wise at least, as to what's going on. There you go. Someone wanted a shader such as a mist, a fire, water, something like that. So here's a water shader. You can see how complex these water shaders could be, and maybe have an idea of why I haven't gone over something like a water shader compared to the difficulty of something like our black and white shader or the outline shader, which is by far much easier than a water shader, especially if you're new. Alright, that'll do it for this one. Take care, have yourselves a good one, and I'll see you guys in the next video.